Hey, everybody. Welcome back to Science Hunters. My name is Sean, and this is where we at VML Health talk about really cool science that we think can shape both medicine and human health going forward. Today, I want to talk to you about one of my favorite topics in all of biology. One of the greatest outstanding questions in my mind is, what does memory look like? You know, memories aren't just something that's floating out there in the ether or on some external hard drive that we can pull down into our brain whenever we want to. Memories exist physically somewhere in our brain, in our neurons. And what could that possibly look like? And how could that possibly be? I mean, I think that is just really super cool question. And there are lots of groups studying stuff like this. We know the area of the brain known as the hippocampus is really important to memory. That's been known for a long time. If you had some sort of surgery that removed your hippocampus back in the 1800s, you might have had some problem with memory. So we've known the hippocampus is important. And over the last few years, we've come to learn that there are certain cells that are known as engram neurons that also can be important. And we also know that there is DNA damage occurring in response to stimuli for memory. So people have been actively studying this new advancement from a group at Albert Einstein published in Nature, really took it to a next level. So they were looking at mice. They had a cognitive test, a fear-based test, to be honest with you. They would shock the mice. And then when they put them back in that environment where they were shocked, you could obviously see different behavior from the mice, which is indicative that they remember being shocked. Okay. If we do that test in mice, though, these authors found that they could find evidence of DNA damage and inflammation in the hippocampus 4 days after the shock. But 3 weeks after the shock, the inflammation was gone. So they did this over and over again and found that the inflammation that was happening in the hippocampus is related to that memory formation, right? Or is thought to be related to that. And they found out that it's based on something called TLR9, which is part of your innate immune system. It responds to broken DNA in your cells. Okay? And the really cool thing that they did is they knocked down and got rid of TLR9 in the hippocampus. And when they did that, and they put these mice back into that shock test, the mice that lacked TLR9 could not remember that they had been shocked before. So we interrupt an innate immune pathway in the brain. It limits our ability to remember. And it is an innate immunity pathway that gets stimulated by broken DNA. Now, I want to talk about broken DNA for just a minute because I am an immunologist, and this is sort of related to some of the stuff that I worked on when I was a graduate student. When you break your DNA, you often repair it in ways that can be a little defective. And that allows you to have a different DNA sequence than you had before. Your immune system uses this to create an infinite number of antibodies. That's how we get all that diversity in our antibodies, by breaking DNA and smashing things together. And that repair pathway creates new sequences that can code for any pathogen we might come across. Could it be, this is so cool, guys, if you get breaks in the DNA in your neurons and then you repair it in some way, that you're encoding those memories in those cells when you repair that double-strand break? It's such a fascinating question. There's an unlimited combination of how you might repair those double-strand breaks, and you could encode those memories. That might be how we remember. Now, look, I'm jumping ahead right at the moment. This is all possibility. But the fact that we know that there is DNA damage, that there's inflammation that is associated with memory, can be directly related to medicine too. For neurodegenerative diseases that cause memory loss, it's completely possible that we may be able to hit that innate immunity pathway, that TLR pathway, and have therapies that help improve memory, whether that's Alzheimer's or any other kind of dementia. This is a pathway that now neurobiologists can explore therapeutically as well. But it is also a fundamental basic biology question that is just so cool. It's got me really excited. I mean, I love science, but this is like one of my faves that we've talked about so far. So I rambled a little bit. I appreciate you guys sticking with me. Please check out this study and the news and views that are surrounded by it, because it is super cool. And I think it could be one of those moments where we really start to learn something about one of the great frontiers of biology at this time. So thank you again for tuning in. Really appreciate you guys, and science rules, man.